Greetings. My name is Matheo Durefeld, one of the partners in BC PassiveHouse. Heather, my wife and business partner, and I founded BC PassiveHouse in 2011. We thought it was a good idea then, but little did we know what kind of journey we were going to undertake. Back in 2019, I received a call from Sean St. Amour, one of our suppliers involved in the passive house industry, and was asked if we could give a tour to Kate Nasson, an architect visiting from Australia. Giving tours was something we became very accustomed to doing, so I thought, why not? We didn't have much planned for this particular Saturday anyways. Kate was fascinated with the development of Passive House in Canada and was on a mission to jumpstart the movement in Australia. When she left that evening, we had shared stories, and we had a new friend. As often happens with new friends, they call back. Kate called in January, asking Heather and I if we would come to Sydney to present our story at the Australian Passive House Conference, which was to be held in May. Of course, we'd love to come, with the added bonus that we could visit our daughter, who is working on her master's degree at Sydney University. Anyways, it is wonderful to meet all of you virtually, and yes, we still visit our daughter on Zoom, and when this pandemic is over, we will get down to visit Australia. On with our story. I'm sure most of you know where Whistler is. In fact, we can't run our ski mountains without the annual influx of Australians, and it is the place where we have operated a general contracting firm for over 40 years. As Durefeld constructors, we specialized in custom homes. In the early days, focused on log cabins and heavy timber buildings. Tourists typically came to our town to ski, but some wouldn't leave without having put in an order for a log cabin. We shipped log and timber structures to the US, Japan, and Europe. We specialized in working with wood and with a particular focus on mass timber. Exporting whole projects taught us that prefabrication makes sense and gives us great flexibility. As our little town of Whistler grew, so did the size and complexity of the homes we built. However, energy efficiency was not every client's greatest concern. There were certainly undercurrents in the industry and in government sectors suggesting that we have to start building more energy efficient structures if we're going to address the impacts of climate change. As a company, we did our part and started taking courses in green building practices to begin to address these concerns. I'm not sure what impact the 2000 Summer Olympic Games had on Sydney, but for Vancouver and Whistler, the 2010 Games were a huge success, and for 6 weeks, we were all caught up in Olympic fever. On a personal level, having Austrian roots, Heather and I viewed the Games through the lens of the Austria House. The Austrians have a tradition of erecting a building to house their team for every Winter Olympics. There was a small group of Austrian entrepreneurs who heard that these Games were to be the first Green Olympics. So their response was, we will show the world what green is. They organized themselves under the banner APG, the Austrian Passive Group, and decided that the Austrian National House for 2010 would be a passive house. I just have to interject a bit of Canadian history into this story at this time. We all think of the passive house concept as having originated in Germany. However, there are strong Canadian roots. This photo is the result of a federal government research project from 1971. The house was appropriately named the Saskatchewan House. For those of you who don't know, Saskatchewan is in the middle of Canada and arguably one of the coldest places on Earth. This house had triple glazed windows, solar panels. It was the first house with an HRV built into it, and the first time a blower door test was employed. This was also the time of the oil crisis, and when we in North America realized that we weren't actually going to run out of oil, we abandoned the need for energy efficiency in either cars or houses. The Europeans, on the other hand, recognized that they had no oil supplies and began to study these types of projects. And as Germans do, they took efficiency to a whole new level. Thus, PassiveHouse was born. Back to the Olympics. Little did we know that when a small delegation of Austrians came to visit us at our Whistler office a couple of years prior to the Games, what actually lay before us. They signed us up to be the general contractor for the project, and then invited us to go to Austria to go to their version of PassiveHouse school. They took us to the factories, we toured their building sites, we ate their schnitzels, and we drank their wine. The house was planned in Austria in collaboration with Canadian architects and engineers so that it would meet all our local codes. The house was fully prefabricated in Austria, so when the 6 containers arrived on site, all the components of the house were there and everything fit. We liked the fact that the house was built out of wood. In fact, the first CLTs and DLTs that were used in Canada were part of the Austria house. There's always a moment in a journey when one realizes that it's worth it. My eureka moment came one winter morning. The house was at lockup and the blower door test had been completed. It was about minus 10 degrees outside and about plus 10 inside the house. The only thing heating this 300 square meter building was a small 1500 watt heater. Normally we have a big portable construction heater to heat our houses until the furnace is hooked up. I remember saying to myself, holy, this really works. I suppose for this story to make sense to an Australian, it would have to be a hot day, perhaps 40 degrees, and the house would be 20 degrees inside with only a small chiller operating. When the Games finally came to a close, we had one final celebration at the house, and Tony, one of our guys, said, we should really build houses like this. We saw that this type of construction can be built primarily out of wood. It makes tons of sense to prefabricate, and it is super energy efficient to boot. It simply ticks all of our boxes. However, that was easier said than done. It was great to want to embark on this new venture, but there wasn't anyone coming to us looking to build a passive house. You have to understand that the concept of passive house was still a foreign concept in Canada at the time. Not wanting to give up on our newfound dream of building to a completely new level, we figured the only thing to do to show people was that it can be done was to simply build a house with local tradespeople and local products. So Heather and I bought a lot, designed and built our Rainbow Duplex project. This became our flagship. We used the house as our demonstration house to show that buildings like this are not only more energy efficient, but more soundproof, have a much healthier indoor climate, and quite literally redefine our understanding of luxury living. However, still not so simple. We didn't have a facility where we could assemble such a project. The best we could come up with that we could afford was a 5,000 square foot warehouse space in Williams Lake, about 500 kilometers away. It wasn't equipped with all the tools and lifting equipment that was needed, but we would make do. As often happens in life, one gets unexpected surprises. Things work out even without planning. We were confident that we would be able to figure out the necessary details to make prefabrication of panels work, and we would be able to figure out how to make the building airtight, even if it's something we hadn't done before. About the same time we were planning this project, we received an application from an Austrian carpenter with a work and travel visa, looking for short-term work. It just happened that Hannes had been employed by an Austrian company that specialized exclusively in building passive houses. Needless to say, Hannes is still working with us. He is now a permanent resident, and we were able to avoid costly missteps or a steep learning curve. In all the buildings we've done, we have successfully reached the Passive House requirements for the blower door test. Sometimes the most valuable things cannot be bought. In our case, knowledge transfer gained us a great employee, and Hannes will likely only go back to Austria for a visit. We knew it was important to showcase our Rainbow project, so we had the house registered with the Passive House Institute in Darmstadt, Germany. The house became Canada's first registered residential passive house. Out of our little remote facility in Williams Lake, we began building one house at a time, and slowly but surely, we began to get a bit of traction in the market, and the passive house concept began to make sense to early adopters. I am now going to ask Lydia to take the narrative from here. Lydia and Kyle, who will touch on building science later, were our first employees and were hired specifically to develop Passive House in our company. Lydia.
So we had company buy-in, we had a product, we had a business, and we had a project demonstrating that we could meet the Passive House standard with our Canadian approach. What we didn't have was customers banging on our door to order our system. I'm going to speak a little bit to what we went through as a company, the process in order to grow, and also a little bit about what happened in Canada as the process of Passive House was starting to take hold. We were a small company. We were building to a standard that, except for a small handful of people, was relatively unknown in Canada. So we had to convince people why they should be building to the Passive House standard instead of the numerous other well-known standards on the market. We were also building using a building method that was not common practice in Canada, so we had to demonstrate the benefits of prefabrication and why they should be utilizing that. But we didn't just need to convince and secure customers. We also needed to convince architects and engineers, building officials, contractors and their subtrades, industry representatives and groups. We needed to sell the Passive House standard, BC Passive House as a company, and prefabrication. Above is just a snippet of the presentations we did in the first couple of years. Kyle, Matheo, and I were constantly on the road. We would talk to anyone who would listen to us, trying to make sure that we hit all of the target audiences. We would do lunch and learns for architects and engineers. We would give presentations at conferences. We would give presentations to local interest groups. We would rent out booths so we could display at home shows. We would give tours of our active and completed projects as well as our facility. We'd give presentations to local municipalities and other government organizations, and wherever possible, we would speak to the media. Our staff also required training. We would send different members to Passive House training or presentations that were happening outside of our company. A couple of our key members also went to Europe to get the full Passive House training and to see what was possible with prefabrication and the building industry. And we continue to have an open door policy at our plant, and we're lucky to have a number of clients that also have an open door policy with their project once finished that gives people the opportunity to experience and feel the inside of a Passive House. These customers are also very open with their experience in living with it in a Passive House, and some of these projects have even monitored their energy consumption, so we have the data to kind of back up our claims. On a personal level, I've been with BC Passive House since the beginning, and I drank the Kool-Aid early on after seeing the results of the Austria house and a quick tour around Europe. getting the Passive House introduction from the people who started it. I also had the benefit of living in the Rainbow Duplex for a couple of years post-construction, which gave me the real life experience. The one thing that I found very interesting was when we were first speaking with the Europeans, they always sold us on the comfort of Passive House residents. And that was their number one sale point, energy efficiency second. And I would always say, yes, yes, of course the house is comfortable, but look at these numbers. And I can say after living in a Passive House for 2 years, my sales pitch now starts with the comfort and I follow with the numbers. And this is especially true now that I've been out of a Passive House and living in a regular constructed building again. Post-Olympics, we were in charge of the building from start to finish. We were able to choose our consultants. We had the benefit of working with a municipality who was familiar with the Passive House standard, had gone through the process of the Austria House, and who was also familiar with us as a builder, as we had been constructing in the area for over 40 years. Outside of Whistler was a different story. We were dealing with varying levels of awareness of the Passive House standard, and we were an unknown entity. So our team would work with the design team right from the start, with the architects and the engineers to work through our process and the details and make sure they understood our system. We would also meet with the local building officials to introduce them to the standard, to our process, the system, and to make sure we got to a comfort level with the approvals that would be needed for offsite construction. And finally, we would work with the local contractor to make sure that they had the knowledge and the skill set to finish the product or the project to the Passive House standard. And you're going to hear this time and time again, and we cannot stress it enough. Put in the legwork up front. Make sure everyone is on the same page. It is one thing to design a Passive House, and it is another thing to execute it on the ground. You need to have buy-in at all levels, and you need to make sure that everyone is working towards the same goal. You're also going to want to make sure that you get municipalities involved early and be an open book with what you're trying to achieve. On top of requiring a new process for offsite approval, we were also using products and techniques that were not commonplace in Canada or didn't necessarily have the appropriate Canadian approvals. This gave the municipalities the opportunity to become familiar and comfortable with our system and the process, ask questions, and request the documentation they were going to need prior to construction starting, allowing us to avoid costly delays later on. So post-Olympics, there were a number of professionals working with Passive House at varying levels. As the standard started to gain a bit of traction in Canada, we built off of that and hosted the first Passive House conference in Canada. And from there, we founded the Passive House Institute. It was the Canadian Passive House Institute West at that point. And we were focused on training and Passive House advocacy. From there, the organization has since morphed into a national organization with paid staff that offers extensive training across Canada and online, that is a resource and support center for those interested in the Passive House standard or working with the Passive House standard, and a provider of events. The association has been recognized by governments across Canada and has been influential in changing building codes across the country. The organization has been invaluable in spreading the word and giving credibility to the standard in Canada. The success of this organization was built off of countless volunteer hours, and I encourage anyone that wants to advance Passive House in Australia to get in touch with your local organization or the national organization and see where you can help. Get involved and spread the word. In the beginning, we would get our job often from our next job during the promotion of the current job that we were working on. And at that time, our makeshift facility up in Williams Lake could handle the demand of the 1 to 2 projects a year we were producing. There became a point where our promotion was paying off and we were seeing an increased demand. And in 2014, we finished construction of our new facility in Pemberton. I am now going to handle it over to Kyle, who's going to speak to you about the manufacturing process and the building science behind our system.
Hi, so my name is Kyle with BC PassiveHouse. Lydia just spoke to you guys about promotion. I guess the other side of that for us is to actually develop a system to build to the PassiveHouse standards. So today I'm going to speak about prefabrication and a bit about PassiveHouse details and achieving that energy efficiency. So first of all, in the background, we have our plant. This was built in 2014. It's about a $16,000 square foot shop space, and it's worked out quite well for us. A bit later, we'll talk a bit about our expansion, but for the time that we built it and the goals that we wanted to achieve, it's worked out for us quite well. This is a look inside the plant. So as you can see, we can build and prefabricate out of the weather, and that really promotes our quality, which is fantastic. We've also got some good equipment in there, so framing tables, robotic chop saws, etc., that allowed us to build quickly and efficiently, and allows for some storage as well. So moving into prefabrication, the first step is shop drawings. So what we'll do is take issued for construction drawings from an architect and the engineer, and then redraw our houses entirely in 3D. And these models we can spin around and we can look into every detail, find conflicts in engineering, and really allow the engineer to sign off on our model, so that we know that once we've resolved this phase, that we're going to build the structure once and have no mistakes. The software then will allow us to put the drawings into 2D, which you can see in the bottom left corner, and those drawings will be handed down to our guys on the shop floor, and we proceed with the prefab process from there. Here's a few views from the shop floor during prefabrication. So I did mention that we had framing tables where we can build precisely and accurately. And we go as far as insulating the panels in the shop. The panels themselves will have the principal structure of a wall or a roof system. We're also including everything like posts and blocking, etc., within the wall, that allows us to basically fit the Lego blocks together of the house. Here's a bit on transportation to site. So we're building and optimizing our panels. I guess one of the main governing factors there is trucking. So panels need to fit on a truck, they need to fit under bridges, etc. So yeah, so we're limited to a certain size and height for a lot of our panels, but can often go quite long, so up to 60-foot spans for wall lengths or for floor lengths. And then we can actually model through our software program, which is called CADWorks. We can model the panels in 3D and place them on trucks so that we can move our panels as efficiently as possible. So this is just a quick look at a loading diagram here. Again, this diagram will get sent down to the shop floor, and our team can get as much as possible out of each trailer. And then finally, when we get the panels to sites, the next step is setup, and we've tackled a whole different range of projects in this regard. The top left corner is probably the most exciting one, where we actually set up a house on top of a mountain. And we've had lots of other interesting jobs as well. So you're looking at floor panels going in and roof panels going in. One house where we actually attached the siding on prior to during the prefabrication process. So basically we were snapping together a house that was a finished product on the exterior. Getting into the details a little bit and actually achieving the energy efficiency standards that we're going for. Air tightness is one of the #1 factors, and prefabrication really allows us to simplify this. On the left is a 3D model of the product that we would actually deliver to site, and taking a look at the inside as we're completing the envelope. We're using OSB as the air barrier, and we're taping up all of the joints and seams in the OSB. And this is allowing us to reach blower door tests in the range of 0.2 to 0.3. The PassiveHouse standard is obviously 0.6, and this has been a very effective system for us. And this is typically a double wall system that we're going to employ. So the taping of the OSB air and vapor barrier would be one continuous air tightness shell, and then inside that we'd then be putting in our service walls. So services for the building can come in at one location, and then we can run services throughout the building without continuously puncturing through our air and vapor barrier and compromising our energy performance. So that wall can be insulated as well. Typically a non-structural wall, and that insulation pack can be added to our overall R value or U value for the shell and fit into our PassiveHouse model accordingly. Thermal bridging is another concept that comes up a lot in PassiveHouse. We've had different ways of addressing this. So for one of the big thing we're trying to avoid here is just beams, posts penetrating through the envelope and causing a major thermal bridge. So in this case, with an interior post, we built a pocket into the panel itself with the structure for the post in the panel, and then the beam can get dropped into that pocket on site. For the exterior, we can put blocking in the panel and then hang our beam systems or have exterior post systems that pick up those beams. So again, we can kind of mimic the look of a beam actually penetrating through the house without actually doing it. And then just a plan view of our typical wall structure here. So this is a 2x10 wall, which is, I guess, about 235 millimeters thick for the structural wall. And on the interior for this specific building, we've got a 2x4 wall that is also insulated, and that's the wall I was talking about before, the service wall. We're typically using blown cellulose fiber in our panel system, and the key here is we can insulate the walls quickly using blown cellulose, and we can also it's also just a good product for the environment. So it's a wood first product, and we'll try to use that as much as we can. And then moving on from the shell that we deliver to site to actually completing the house, BCPH is providing a structural insulated system, and if we're not acting as the general contractor, then the site general contractor would complete the house from the stage that from our setup. We typically leave the house once we've put the package together, and then done waterproofing systems to protect the product that also form the main layer of waterproofing system for the house. So the examples here you can see are a breathable membrane on the wall system, and then also a breathable membrane that would form the secondary membrane for the roof structure. Windows and cladding with PassiveHouse. One of the key components to, well, I mean, I guess there's three key components to energy performance in windows. One is the glazing, the second one is the performance of the frame, and the third one is thermal bridging through the frame. You can see here that this is an energy efficient window from OptiWin, is a window we've brought in from Austria. And it's a wood window that's aluminum clad, performs quite well, it's triple pane, and then you can see the details on the exterior where we're actually over framing the window and insulating outside of the frame to cut down the thermal bridge, or what's called C installation in PassiveHouse speak. There's a few more residential homes that we've done. Some of these are certified to PassiveHouse standard, and some of these are not. So, but all of them kind of have the goal of a low or energy efficient house. The one in the top left corner, which is one we just completed, which is a house with a lot of character, is an interesting challenge. But the form factor for this house, for example, was not ideal, and they wound up certifying to the PHI low energy building standard instead. Whereas the house in the middle right there is an example of a house that certifies quite easily. It's more like a box shape and has a very efficient wall space to envelope space in terms of the heat loss elements of the house. Talked a bit about reducing energy use throughout the building's lifetime. We also talk about life cycle energy, which is the next thing that seems to be in discussion, where here in British Columbia, just as it concerns how much energy input you're putting into the building when you build it. And for us, our focus has always been wood first, because that's seen as a carbon neutral construction material, whereas steel and concrete are not so much. So by the sounds of it, the upcoming code changes will incorporate both PassiveHouse, or decreasing the energy use of the building itself, and also bringing down the energy input to building the house. The carbon summary on the right there shows that by building the specific house out of one of our specific houses out of wood, that we actually saved about 50% of the equivalent of the life cycle energy use of the house. Some more projects just within that we've built through BC PassiveHouse that aren't necessarily again certified passive houses, but where we've been able to assist with the goals of the project. So some of these are remote sites, they're First Nations sites. We've prefabricated larger roof systems so that we can bring their structures out of the elements, especially here in Canada with cold and snowy winters that move in quite quickly. And then also energy efficient systems that aren't necessarily going to achieve PassiveHouse standard, but hopefully lower their energy bills in pretty harsh climates. A couple more examples here. First Nations projects on the left as well, and one really large roof structure we did on the right. A couple more in Whistler. Again, the one on the top left corner is an example of the types of buildings we can do in prefabrication. So we can do very complex structures. They're not always going to be certified to PassiveHouse. In this case, the form factor wasn't working out for us very well, but we can again bring down the energy loads for a custom house and achieve some pretty dramatic modern architecture. Same thing with the next one in the top left corner. Again, not a PassiveHouse, but it's super efficient envelope. And the one in the bottom right corner is, I was showing the photo with the helicopter setup earlier, and this is the completed house. So this is on top of a range of mountains that extends between Whistler and Blackcomb Mountain where we are. And it's offering a place for ski tours, so backcountry skiers to post up for the night and move on with their ski touring the next day. And lastly, I've got a video here, and this is our this is a project we finished last year called the Whistler Legacy Project in Whistler, and this is a certified passive house. It was fully prefabricated by BC PassiveHouse, and we were fortunate to be able to do a time lapse of the entire building. So for the 15 days it took us to crane the floor and wall and roof, shear wall panels. Basically, when we're prefabricating, we want to include all of the structural elements to set up the house continuously. So it was a pretty exciting project to be a part of, and we were able to offer this solution to reach the PassiveHouse standard for this public project in our local community. So I'm going to play this video, and it's about 3 minutes long, I believe.
The very first step is I get in contact with the architect, the designer, and with the engineer. We're having a kickoff meeting where we design the panel layout, what BC PassiveHouse is building and what is built on site. The project is in Checkhammers in Whistler. It's a 4-story building with 24 units where we deliver the exterior walls, the load-bearing shear walls, and the subfloor panels, the stairs and the roof panels. Once I get the approved drawings back from the architect and the general contractor, this is when we start ordering the materials and start producing single shop drawings. We have optimized cutting lists as well. From this 3D model himself, we can produce material lists for the wood supplier. We have optimized cutting lists for the production as well to create a minimum waste, and as well single panel drawings with the weight on, and on top of it loading plans. Then there is no surprises. Even on site, we know the crane location, we know what size of crane we need based on the panel weight. This building has over 200 panels where the average panel is 40 feet long and 12 feet or higher, and around 2,500 and 3,500 pounds, what we erect with the auto crane on site.
Currently, we're focused here at BC PassiveHouse on a project with Whistler Housing Authority, which is an initiative for affordable housing in Whistler. Building our products with a roof over our head means that we have a controlled environment to assure that our structural components are where we want them to be. Using high-tech equipment and digital systems, we can ensure that our panels and our systems are built effectively and accurately. Our panelized systems are fully waterproofed in the shop so that when they get to site, we have control over quality for our product on site.
So the legacy apartments will be built to the PassiveHouse standard. This is a comprehensive modeling system that has become the gold standard for energy efficiency in construction. BC PassiveHouse will look after the envelope component of the system, and the three key principles here are increased thermal insulation, high levels of air tightness and reduced thermal bridging. So the legacy project uses a double wall system. The structural wall is the component that you'll see during the setup phase. This is a deep stud wall system that is insulated in the shop with cellulose fiber insulation. And then there will be a secondary wall that's framed on site that will be insulated as well, and that will complete the insulation pack of the building.
My role here as project manager is to oversee all the various trades involved with the project. We started here at the same time BC PassiveHouse started in their factory. While we were building the foundation, working on the concrete, and BC PassiveHouse was fabricating panels in the factory. So the first step is to come on site and with survey data install the plates, wood plates on the concrete to make a very accurate starting point for the panels to be installed. The next step is to bring in the panels and start assembling the building. Obviously, it's really nice to do that in good weather, but we have to make arrangements to be able to proceed, or at least be able to protect the building during those weather events.
Thank you for indulging us on our little journey. As you can see, Heather and I did not travel this road alone. We had a group of dedicated, engaged staff. You can see that in Kyle and Lydia, and they're really just the tip of the iceberg. I mean, it was a whole group of us that did this. If we have any advice for you, it would be simply, you don't have to do this alone. You don't have to invent anything alone. There's a wealth of information out there. Copy and adapt. A lot of people have traveled this road before, and they are generous. Just be gracious. People like to give when you're gracious. So what does the future hold? What does our future hold? Are we done? Every once in a while I think we're done, but maybe we're just at a crossroads. One of our partners, Eric Karsh, if you look up the book, The Case for Tall Wood, he co-authored this book with Michael Green. And it's all about, you can see on the diagram beside us, beside me, it's all about tall timber buildings. And there seems to be a bit of a race in the world, who can build the tallest building, who can build the tallest wood building. Does it really make sense to build them 20, 30 floors tall? But it can be done. I think really our focus will be to build taller buildings, but to make sure that they are energy efficient, that they're well wrapped, and that they can in fact be passive houses. So guess what? Our current facility is a bit small, and we are in expansion mode. We have to add equipment, we have to add tools. We're adding about 2,200 square meters. In order to do what we're planning to do, we've outgrown our current facility. So here we go again, and for the fun of it, we're gonna play a little video that we took a couple of months ago when we first set up the panels. to leave you with some advice that one of our mentors gave us when we first started our own journey. And he said, if you want to go fast, go alone. And if you want to go far, go together. We wish you luck in whatever your journey is. And Heather and I both thank you. Visit our website. We'll update that once in a while and let you know where we're at. But good luck and thank you.